Oftentimes we're interested in the wetting properties of the pair of fluids with a particular surface. And we can address that by looking at some additional parameters. But first, let's modify our domain to include a surface. And I'm going to move this existing line of solid nodes here just up a little bit so that it is roughly in the middle. Let's see. Huh. That's pretty good. Okay. Now let's look at the params.in file. And for the first time, we need to start thinking about these g-adds coefficients. And the way these are set right now, they're equal and they're set at 0, so there should be no attraction or repulsion from the surface. And hence the two fluids should behave equally around the surface. And for the initial condition, we're using a rectangular domain, which actually is, let's straddle the line. So from point 4 to point 6 in both x and y. And let's give this a try. And we can go directly to the output files and look at what's happening. Here you can see our initial condition. It doesn't quite straddle the line perfectly, so we end up with two different drops of different sizes on different sides of the line. But when this completes, and I'm not making any guarantee that it's truly at equilibrium yet, but the basic shape seems to be in place. Since there's no preferential adsorption, if you want to think of it that way, between either compound here, the contact angle on both sides is about 90 degrees. Now let's start changing these g-adds parameters to make the blue, the 0 component, more strongly adsorbed. And remember that a negative is the attractive force here. And that's probably really enough to get this to go to a lower contact angle. It will be adsorbed preferentially compared to the other one, the other fluid. So we have dropped the contact angle considerably. Give it a few more seconds. And we're looking at something now that seems to have a contact angle more like perhaps 30 degrees. Obviously, this is a very coarse domain, and you need to use a larger domain for accurate measurements. Let's go the other way now. Let's try to change the wetting characteristics so that the blue fluid becomes non-wetting and the red becomes wetting. So to do that, we would make the red fluid, which is number 1 or substance 1, have a strong negative, and we'll change the other one to be a moderate positive value. So that would be a repulsion now for that one. Let's see what happens. And for those of you following my book, or our book, if you will notice, the magnitudes of these coefficients I'm using are quite a bit different, and I apologize for that. Apparently there were some bugs in our code that were subsequently fixed. I think what's going on now makes pretty good sense. So from our square initial condition, we've separated into two droplets on both sides, but obviously the blue fluid is no longer wetting in this case, and it's has a very, very high contact angle.